All right. Okay, so let's keep going then. Let's do some more stuff. So I want to do some more examples with systems of linear equations. So here we have this system. This one's a little bit different actually, as you can see, mostly because of these fractions. Mostly because of these fractions, okay? Now, you can keep them there, but personally, I would really eliminate them if you can. That's what I would do. Okay, so how do we do that? Well, it's just like what we did in chapter 1, right? Namely, in chapter 1, we had linear equations. Wait, let me just, forgot to do. So I forgot to delete the ink for the stuff I wrote on the slide from last class. Sorry about that. Uh-oh. All right, here we go. Nope, not there. Come on. Here we go. So again, we're going to solve this. So again, what we want to do is eliminate, okay, those denominators. And just like what we did in chapter 1, when we solved an equation in one variable, but there were fractions, we multiplied both sides by a common denominator, right? I mean, the least common denominator was really the best one because you'll have the least amount of simplifying. But here it's easier because we have denominators here that are the same. So we could just multiply both sides by that denominator, which is 7. And that's the first thing I'm doing. Right? Let me just draw the 7 in. Can't believe I missed it, but I can't believe I forgot to type it in, but I guess that's okay. But we multiply both sides by 7, and then we distribute, as you can see. And that's good because then this 7 will cancel this 7. This 7 I just drew in cancels with this. And now the fractions are essentially gone. So we get -5 minus 11x equals minus 7y. Okay, so this is our system we have to deal with now. Okay, this is what we're dealing with. Okay, so what do we do? Well, we want to solve this, and again, we're using elimination. Remember, if I tell you to use a certain method, you have to use it, okay? If I don't tell you what method to use, then you can use any method you want. So for elimination, I mean, what I did was I eliminated the y's, mostly because I figured that with the 2 here and the -7, I could multiply the first equation by 2 and the second equation by 7. And what would happen is you'll end up getting -14y here and 14y here. And what that will do is, the coefficients will be the same except for their sign. In other words, this is what I did. I mean, do you have to do it this way? No, you could have eliminated the x if you wanted to. So what I did was I multiplied the first equation by 2 and the second equation by 7, right? Because then, we distribute the 2. You get -10 minus 22x is -14y. Here, we get 49 plus 35x. When you multiply the second equation by 7, equals 14y. But now you can see that the y's, their coefficients are the same, except they're opposite in sign. So if you were to add them, the coefficients would be gone. Right? In other words, the variable would be gone. So if we add them, as you can see, these cancel, and we get 0. Or 0y, but same thing. For the x's, you get -22x plus 35x, which is 13x. Here, -10 plus 49, which is 39. So we have 39 plus 13x equals 0. Okay. And so we want to get x, right? So we have to isolate it. So we subtract 39 from both sides, and we get 13x. This should be an equal sign there. I guess it's all right. So we have 13x equals negative 39. And so we want x, right? So what do? We divide both sides by 13. Right? So we get x on the left, right? Here, let me draw it in. We get the 13s here. They cancel. We get x equals negative 3. That's really the hard part. X equals negative 3. And now once we know x, we can easily get y. I mean, basically, you would have to go back to one of the two original equations. I mean, I went to the one without fractions. You have 7 here. Let me show you. 7 plus 5x equals 2y. What I did was I interchanged both sides, which you can do. I replace x with negative 3, as you can see. And then we solve for y. So we have 2y equals 7 plus 5x. I replace x with negative 3. And we get 2y equals 7 plus negative 5. And so, of course, that means 2y equals negative 8. Then we divide both sides by 2. Excuse me. And doing that, we get y equals negative 4. So that's what we get here. So we had x is negative 3, y is negative 4. So the only solution is negative 3, negative 4. And even though I said you had to use elimination, you can always check your answer using Desmos. Right? You know, you could graph it and you can see, oh yeah, they intersect at the point negative 3, negative 4. So yeah, we're good. As a check, you can use it. Or of course, you can just replace x by negative 3 and y by negative 4 into the original system and see that you have a solution. Are there any questions on this? Okay, well, let's do another one then. So this one's similar, as you can see. Here we have denominator of 3. You know, both of them are the same. So it's a little bit easy. So it's not so bad, right? Because what we can do is just eliminate that denominator easily, right? What we can do is multiply both sides by that denominator. You know, it's just like the previous system, except instead of 7, you have 3. You know, you want to eliminate, so you multiply by a common denominator. So the first equation, we're going to multiply both sides by 3. Right? And it distributes, so we get 3x minus 3 times 1 over 3 times y equals 3 times 11 over 3. And so what happens is, you know, here we get 3x, the 3's cancel, and we get y, like so. And we have 3 times 11 over 3. And of course, the 3's cancel, we get 11. That's what we get there. So now the system becomes this, as you can see. Namely, we have 3x minus y equals 11, and x plus y is 1. Well, hopefully here it's not so. Hopefully it's not so hard what you can do, to see what you can do, right? You can easily eliminate y just by adding. I mean, you could eliminate x if you wanted by multiplying the second equation by negative 3, but I personally would just add the equations. these y's cancel, as you can see. We get 3x, right? Minus y equals 11, plus x plus y equals 1. So the 3x plus x becomes 4x. The y's are gone, and we get 12. So the equation is 4x equals 12. So, but remember, we don't want 4x, we want x, so we can divide both sides by x. Now, how do we do that? Well, these x's cancel, right? And we get x equals 3. 12 over 4, which is 3. Now we know then an x value, right? We know an x value. How do we get a y? We have to replace x, we have to put x into one of the two original equations and solve for y. So I chose this one, I thought it'd be easier. So we have x is 3 plus y equals 1. So we have negative 3, you subtract 3 from both sides, right? We have y equals negative 2, right? Again, you want to get y all alone. So this is after replacing x by 3. You know, you subtract 3 from both sides, you get y equals minus 2. And of course, that tells us the only solution is 3, negative 2. So that's the only solution. All right, that's good. And again, you could check it by graphing. I mean, Desmos really, well, graphing is a way to solve it. And even though I said to use elimination, you can check by graphing. And yeah, they intersect at 3, negative 2, so we're good. Any questions on this? Okay. Well, let's go back to some absolute values. First, let me take care of the